we're looking at the definition of unit of force. So first we have absolute unit of force, and the other one we have is gravitational unit of force. Now, what is this absolute unit of force? It's quite simple actually. So we know that force is equal to mass into acceleration, and the SI unit is Newton, and this is your formula, right? Now we need to define, right? So we need to define absolute unit of force is nothing but what we are trying to do here is we are trying to define 1 Newton of force using this formula, using m into a. So how do I get 1 Newton? Basically, let me ask you this way. How can I get 1? When I multiply two numbers, how can I get 1? I can go with 2 and half, 2 into 1 and half, 3 into 1 by 3, 4 into 1/4, 10 into 1/10, or I can just do this. Do you guys agree? Now let me write the unit. 1 Newton is equal to 1 kg into 1 meter per second square. Right? So we are looking at the change in velocity will be 1 basically per second. Per second, that is. That's nothing but your acceleration. Do you guys agree? For example, let me take up an example. Say we have an object. This is 1 kg mass. Say that initial velocity is 10 meter per second. Now, I will apply some force F, which has for a time difference of 1 second, and you will end up looking at this. So from this, what can you tell? Well, the change in velocity here is 1 Newton, because 11 minus 10 is 1. In how many seconds? In 1 second. And so the acceleration is 1 meter per second. The mass is 1 kg. Therefore, with all of that, my force is 1 Newton. This is what I can conclude. You guys agree? And that is your absolute definition of force. Okay, it's a very simple statement. If I take up a 1 kg mass, apply a certain force. If the velocity changes by 1 meter per second and the duration of me applying the force is 1 second, then the force is said to be 1 Newton. That's it. Right? So that is your definition. Now, we have one more definition. Gravitational unit of force. It's bit weird. So I'll take up example and let you explain it to you guys. Gravitational unit of force. Now, so let me take up the surface of the earth. So near the surface of the earth, what do we know? We know that we have an object, and if I let it go, it will accelerate at a rate of 9.8 meter per second, if you guys remember from your previous grades. And we did it actually also in quite a few questions in the previous chapters. So if I have an object of 1 kg, same funda, with an initial velocity of 10 meter per second, and I apply a certain force for a time duration of 1 second, and let that force be F. If this object turns out to be with the velocity of 19.8 meter per second, then this force F is nothing but your gravitational unit of force on the surface of the earth. I don't know if that on surface of earth. Let me check the language though once. I guess let me write it properly. I'm not very happy with it. At least let me write shortcut. Gravitational unit of force on Earth is this F. Okay, so we can also write subscript. Now, my question to you guys is, why I have written Earth? So is it different on the moon then? It is. Gravitational unit of force on the Earth is different and on the moon is different. So it will vary from place to place. Absolute unit of force is constant. Absolute unit of force is constant throughout the universe, while gravitational unit of force varies from place to place. For example, same thing I can take up. Okay. And I can talk about case moon. Instead of Earth, I can talk about moon. And on moon, we have an acceleration due to gravity similar to what we have over here. The acceleration, the value would look like something like this, 1.625 meter per second square. So basically this will be 11625 meter per second. The same funda, same concept, same object, same everything. But in place of E, we're talking about M. So here Fm is your gravitational unit of force on moon. Fm is gravitational unit of force on moon. Okay guys. Okay. So what we just learned was how to define the unit of force. So first one is what we use most of the time. I mean all the time actually, honestly. And that is your absolute unit of force. So it's quite simple. We need 1 Newton. So if we apply 1 kg, if we apply a force of some certain value on a 1 kg object and its change in velocity is 1 Newton, my bad, 1 meter per second in 1 second, right? The change in velocity is 1 in 1 second. Then the force applied is said to be 1 Newton. Similar idea, but if the value changes by a amount of 9.8, what we have is a gravitational unit of force. And if it changes by a value of 1.625, what we have is we have gravitational unit of force on moon. Okay, so that would be a small introduction.